So distance learners, I've got a couple emails from you guys saying where to turn in your homework. Read every slide. I'm not collecting assignments until next Tuesday, so I'll put a form up for you guys then. Today we're going to continue with solving differential equations with separation of variables. But before we do that, we're going to go take care of warm-ups. Distance learners, yours are linked on yesterday's slide. Guys here are just keeping them in a notebook. Once we're done, I'll deal with them. So yesterday we did 1 through, did we do 1 through 5 or 4 in here? 4. So okay, I did number 5 and 6 now. So actually we're going to have to do, I don't know why it says 10 through 15 there. We have to get 6 through 10 done first. Actually, for you guys, 5 through 10. So we're going to hop on there, and then we'll go from, let me see, I got to find mine. Not that, not that. Here it is. All right, now again, we do these together. Eventually, you'll be doing them on your own. Let's just start with 6 since it's up here, and maybe I'll go back to 5 when I'm done or tomorrow or something. So this guy, we see lots of these tables. Usually when I see a table like this, I kind of think it's going to be some sort of a left, right, midpoint trapezoidal thing. We have on a certain day a rate. So this is already a rate in people per minute are passing through security at an airport. So R is a rate. It's measured in people per minute. T is in minutes since they opened the security station. So just kind of absorbing what this problem's about. I'm supposed to use a trapezoidal sum to find how many people. And remember with trapezoidal sums and left and right, we end up multiplying. So our people per minute times minutes will become people going through the station. I chose a one with trapezoidal because usually left and right are easy to remember. It's the trapezoid one that we forget. See if you guys remember this setup. All right, how do you do the trapezoid? If you don't know, then don't guess. Make a fake graph. Actually sketch the trapezoids, which I'll do, but I want you guys to do it without sketching. See, 0, 5. Let's call this 10, 4. Way out at 40. I'm at 2, and at 60, up at 3. There's my dots. If I were to make a fake graph, I think I could assume it probably went something like this, but I don't know. But when you're doing trapezoids, you have that, that, and that. And so if we can remember how to get the area of a trapezoid, kind of got it. Who remembers how to get the area of a trapezoid? Let's ask. Who should I ask? How about you, 40? Do you remember how to get the area of a trapezoid?
1/2 height times base 1 plus base 2.
Yeah, and yes. And if she had to sketch it, that didn't take me very long to sketch it. I mean, I kind of budget 2 minutes. It took me like 30 seconds. So if you have to sketch it, sketch it. I'm looking for my pen. There's my handlebar. Usually there's like a little, do you guys see like a little, oh, there it is. It's hiding right there. So when she said 1/2 of the height times the sum of the bases, come on, now leave. Oh my. Go away. So the height of the trapezoid is the distance between the parallel bases. So it's this, but on your table it's just that. So, and I'm doing this both ways just in case, so like if Peyton were to forget, she could default to just kind of sketching a fake graph. Base 1 is this one, and base 2 is that height. So remember, that becomes 1/2 of the height times base to the left plus base to the right, just what Alicia said, right? And same with the next graph. It would be 1/2 of the height, which would be this. So it'd be plus 1/2. Can somebody who did it right calculate it out so we don't waste time with arithmetic? 1/2 of the height times the base to the left, 4 plus the base to the right. And then we'd have the third one would be this guy, 1/2 of the height, base to the left, base to the right. And the third one's height would have been 20. Somebody who did it right, what do we get?
B.
B? Do I have a backer on a B?
Yeah.
Yeah, thank you. All right, so what's the downfall of doing it this way, Clocker, do you think? Distance learners, I'm pointing at the graph. What's the downfall of like thinking it out with a graph? It just time. Yeah, so take it if you need it. You know what I mean? These little tricks are to save time, but if you don't remember them, theoretically, you're just doing what Alicia said. Half of the height times base 1 and base 2. All right, that one's done. Next one. Oops, I feel like 7 must be down on the bottom here. There we are. Total area. This is our last chapter. We don't have a calculator though, so this one's kind of a bummer. Because remember when we do total area between two regions on an interval, we need to see the graph because we need to see top function and bottom function. Y equals 3x is not going to cause me any problem. That's just a steep line, right? My problem over here, Luke, is do we know how to get a sketch of that without a calculator? You should know what it is, right? It's parabola. Does it open up or down? Up, yep, they're saying up. So I need to sketch it though. What do you think is a good way to sketch that? What do you think, Priestley?
Plugging a point in the interval.
What did you say, hon?
Plugging a point in the interval.
He said start plugging in points. Sure. What do you think my 2 favorite points are? What do you think? Think about it. I could find 2 points really easily, and not the vertex. I could find where that equals 0, right? Pretty easily by factoring. So I'm going to let that help me graph it, because I know it's going to hit at 0, 0, and at 1.5, let's make that 2, and at 1.5, 0. The vertex has to be in the middle somewhere, right? And I know that it opens up, so I know it's going to be going like this. What do you think? Would that help at all, Lily? I mean, I just need a sketch. Here's the problem though. It says to integrate from 1 to 4. Well, I can see at 1, the line is the top function. So I know I can go 1 and I do top function minus bottom function, right? The problem is I'm not quite sure where that is. I don't know if that is at 4, and I can just go 1 to 4, or if then I have to swap out top and bottom function. Lily, how do I decide what this point is right here where my parabola crosses the line? Because if it happens before 4, I need 2 integrals. Yes, go ahead and do that. Set the 2 functions equal to each other. I know one intersection's at 0 because I can see it. And I can see that 0, 0 works in there. I'm in search of the one over here. I'm not quite sure where that happens. So you go ahead and blurt it out when you find it. It'll be nice. If you don't have a calculator, it won't intersect at like 1 7/11. It'll be like 2, 3, 4. So some people like to just start plugging numbers in, but whatever's faster. Did you find it already? 2? Do we have a background of 2? And 2 I would have, my graph isn't very good, but 2 would have been a good guess. It might have saved me some time if I plugged 2 in. Do I get 6 out of both? And the answer would be yes. So this would have to be done, right? Then what? For the next chunk, I'd have to go from 2 to 4. And how would my integrand change? What do you think, Mel? Exactly. I need to flip the top and the bottom. So then I'd have the 6x squared minus 9x minus 3x. Why would this one make you crabby if this one had been your number 7? This one's a time sucker, isn't it, Caden? I almost, when I would read that, I would breeze past it and go back to it at the end. It's a time sucker because I don't have a calculator to graph it. I have 2 integrals. I have to integrate by hand, right? So this is one I'd probably save. I'm not going to do all the antiderivative and arithmetic. It's one of those up there and I don't want to do it. You should know how, right? It's not hard. It's just kind of like, that's going to take me a while. So let's go to our next one, number 8. The function f is defined by, what do I know about f? I know it's a parabola that opens up. I have no clue what k is. I'm in search of it. If the line tangent to the graph at x equals -2, so I'm going to draw a tangent line here. I'm going to say that was a maybe at -2, comma. I don't know. I like to get a sketch down. All right, it says, is parallel to another line. All right, where's the other line? I don't care. Somewhere there's a parallel line to it. And that line is 2x plus 3. How do I find k? Just going to let it settle for a second. I've got a tangent line and another line that run parallel to each other. What do I know about them? Same slopes. The slope of the black line's obvious. Oh, I better not go too far from here. I don't have my headset up. The slope of the black line's obvious. What's the slope of the black line? Go ahead, Ellie. 2. Okay? She said the slopes have to be equal. Well, there's the slope of the black line. What's the slope of the red line? The what? There's one word I want you to say. Slope of a tangent line. Derivative. Okay? It's the derivative of this. It's 2x plus k at x equals -2. This is not a hard question if you understand what a derivative is. But do you see how if you just know how to take them, this would be hard. You wouldn't know that. But this is actually easy arithmetic. This is just 2 equals -4 plus k. K's got to equal 6. Done. I would not call this a hard question unless you don't understand what a derivative is. Right, Sam? It's pretty easy. These have to run parallel. Slope is obvious. Easy derivative to take. It's pretty straightforward. And number 9, I must have glossed over. Number 9. All right. So Caden, I've got, not Caden, let me pick on somebody over down, Chunkster. Are you ready? He's nodding. All right. I have a piecewise function. I have f of x equaling x. Y equals x. I would sketch that. What does the line y equals x look like? Do you know, Max?
So, 1.
Well, it is a line, but it's the line y equals x whenever x is negative. So do you know what the line y equals x looks like? Like I know you know it's a line, but do you know which line it is? Help them out, Harrison. What is this line? Like, what does it look like? Yes, those of you at home can't see him. He did that diagonal 45-degree cut. So it's this, -1, -1, -2, -2. Why am I only doing it to the left? Because that's what it says to do. Okay. How about, let's go to Bryce. How about the line y equals 2? Because that's what I've got everywhere from 0 on out. What does that look like?
Horizontal.
Yeah, so you're just going to go up here and you're going to go like this. Okay. I'm supposed to integrate. All right, so who haven't I called on? Kalia. When I'm supposed to integrate, what am I supposed to find? Yes, you guys, I'm going to repeat what you guys say because I'm recording. The area under the curve and above the x-axis. So I'm going to be from here to here. And then I'm going out to 2 on this one. How do I figure out these areas? There's 2 options, a fast way and a long way. How about you, Sam? How would I figure out the area of that yellow stuff?
When we just like do like 2 times 2 for like the rectangle.
Yeah, he's using geometry and that's the fast way. Yes. Where did his 2 times 2 come from? Because we're integrating out to 2, up to 2. This one's 4, positive, correct? And this one's a triangle. So I would just do 1/2 of its base length, which would be 4, times its height, right? So what's its height down here? What's its height? Let's say, I don't know. You should. 4, right? Because it's -4, -4. Although this is 8, the answer is not 12. I don't even see 12 there, which that would have been a good distractor, I think. Why? What this is really because it's below, it's a -8. So that's A. Do you think that one was hard, Peyton? No, not if you understand what do you see how Like, you have to understand what these things are, not just be able to go, well, I can do the antiderivative of x, it's x squared over 2. Well, okay, but do you understand what you're finding? Area. All right, last one for today. Number 10. I'm just going to let you read it. F is continuous. They're telling me who u is for u sub. And they're asking me which integral is the same thing. They're testing your teacher on this one. Did your teacher teach you that when you do u sub, you have to change or know how to change the limits? That's what this is testing, okay? So they're saying let u equal 1 minus 2x. And this is all in terms of u, so your limits have to go in terms of u. So just knowing that, 50-50 guess, right? I told you, you won't have to do it. You're going to have to recognize it. Because some teachers don't teach, they get it all in terms of u. They just say back sub to x. But then those kids don't know how to answer something like this. So my new limits, let's see, I was 1. So I'll go from -1. And 3, so that'd be -5. Is that a 1 under there? Is it? No. Okay, so that didn't quite get me the answer. But my next thing is my du. What's my du on this one? How about Sam?
Would just be -2.
-2 dx. So that's not what I want. So I fraction correction it. So which one's the answer? D. Okay. Did you do way harder ones than this in Unit 6? This is just testing. Do you know that you need to get everything to you? All right, that one's done. We're not going to go back and do number 5. So what I want you guys to do while I'm getting this set to load is you're going to do the first one on this new. I'm doing different notes. So we're going to do these 4 together today. I want you to go do number 1 just to bring yesterday back. Those of you at home, I'll show you what that number 1 is because I didn't link it. We're changing notes out today and they're not wordy, so you guys can just write them down. So they're working on, they were sitting right, they're on Peyton's desk. All right, so those of you at home, the number 1 I'm telling them to do, which you should as well, just to refresh yesterday's because today's piggybacks on it. They are working on this. I'm going to wait for that spinning wheel. Number 1, there's no prompt on there on purpose because I want you guys to know what you would have been asked to do. It would have said solve for a general solution to the differential equation. Or find, I'm going to write that up here. So those of you at home, you should actually be doing that too. Just to bring yesterday back, because there's a twist to it today, otherwise it's pretty easy. And we're only going to do 4 examples and then be done. Find the general solution is the prompt. All right, so I'm going to get this. You know what, I might as well just keep recording. I wonder how long this will. I'm going to pause while you're doing that. I'm hoping it won't cut out on me, but. What'd you say? Yeah. Who haven't I talked to today? Tucker, do you want to kind of start me on this? And I want you to write this prompt, by the way. Just take a second to write that up there and underline the word general, because the only thing that's going to change today is that's going to be a different word. It's going to add to the process. So Tucker, from yesterday, what did we do first?
You multiply the y over and multiply the x.
Yes. Do you remember what that's called? What did you just do for me, Tucker? Doesn't matter that you don't know that what it's called, but it's not just. What did he just do? Separation of variables. Yeah. So he just did separation of variables. Why did he do that? So we can do the next step. What was the, Annika, you weren't here yesterday, but did you take notes? What's the next step then? Yeah, now I can integrate. And then Bryce, it's just about antiderivative. So go ahead and give me an antiderivative of the y squared.
Y cubed.
Yep. Over. Perfect. Technically plus C, but what did we say, Felicia, to do with the C? Yep.
So the 3y.
Yeah.
So we're another
Oh, it's a 3, yes, so that's gonna actually be over here, sorry. I'm gonna keep the constant, everything, not y over on the right. If you move the 3 over, you're just gonna have to bring it back later. All right, yes, thank you, I forgot to leave that constant in there. All right, so what's up next? Did I do something wrong still?
Wouldn't it, okay, wait, so,
Yeah.
wouldn't it cancel out
Yeah.
with the y?
Because
Y squared, y cubed, oh, so you brought it over and then canceled it off. That'll work too, doesn't really particularly matter.
So,
Yeah, for this one it kind of does since it is a 3. So yeah, go ahead if you want to bring it over and then it'd just be y cubed. Is that what you were talking about, Bryce?
Yeah.
Okay. Yep, that'll work too, it all washes out. So usually they'll keep your constants out of the way because they usually don't disappear. Had that been a 5, you'd eventually have to divide by 5 to get rid of it. But it was nice that it was a 3, so go, that's totally fine. How about, Charlie, what's the antiderivative of x? And how about sine? Perfect. And then we put c here. So are we good so far? Then we just need to take a cubed root. So y is equal to the cubed root of x squared halves minus cosine x plus c. Are we good? So how is it going to change today? That word general is going to be replaced with the word particular, and they're going to tell you a point that your particular solution needs to sail through. So I'm going to think of one here. Okay, so go ahead and write through 0, 1. Here's now what happens. This plus c is an infinite number of curves. And we talked about that yesterday, whose derivative would be this. I want the one that sails through 0, 1. What that means is I need to figure out what c is. Does that make sense? How do I figure that out? I put in a 0 for the x. And I solve for c. And I said 0 in for x has to spit out a 1. So then I would get 1 is equal to the cubed root, right? I'm going to cube both sides. So this would be 0. What's cosine 0? 1. So that would be negative 1 plus c. I'm just cubed rooting both sides. What's my c? 2. So the particular solution that sails through that point is y is equal to the cubed root of x squared over 2, like Charlie said, minus cosine x, like he also said. But now I have a specific c, and my c for this problem is 2. All right, why is it 2? Because that's the only constant that'll cause me to sail through that specific point. Does that make sense? The question becomes, when do you solve for c? And I'm going to tell you, you can do it any time after you integrate. When? Anytime after you integrate. So kids take that directive differently. Like my BC kids, I have some of them who always wait till the end, like I just did. I have some who always do it immediately after, and they find C right here. And then I also have some who do it depending on the problem. Does that make sense? I think until you've done it a lot of times, you should pick either always right away or always at the end. All right? When I make keys, I do it when it feels good to me. Like when I'm like, oh yeah, it'd be nice to plug it in now. But it doesn't matter. So watch. I'm going to go back over here. I'm going to erase this, but remember we got a 2. Okay? So just remember that. I'm going to go back to the beginning. And erase all of this right here. And you guys can just branch off. I'm trying to erase it. So I'm going to branch off and pretend that Bryce is nervous, waiting till the end to find Carl because he thinks, well, I might forget. And so he's like, I can do it right now. Watch what he would do right now. He would take his y value of 1 and put it in right now. That make sense? And then he would put a 0 in right now. Minus cosine 0, which is minus 1 plus c. What's he getting for his c? 2 right now. It won't always be the same. It depends on the manipulation. So I'll show you one. It'll always be the same at the end, but here, I'm going to show you with this one. All right, so let's go take a look at this guy. This prompt, would it have said find the specific or particular solution or find the general solution? What do you think? Would this say find the particular? How do you know that? What's the trigger? It gives you a point you need to sail through. All right, so we're going to start. By the way, I messed with the variables for the first time because I want you to know what it means. Who am I solving for? X as a function of t. How do I know that? It's always the what? Top variable. And we call it the dependent variable. Okay? So you're used to it being dy dx and solving for y. Well, this is x as a function of t. That x is eventually going to be something more like a w, or maybe a d for dollars, or a w for weight, m for money. Something's tangible will be changing over time tomorrow with our word problems. So I still need to do what Tucker did on the other one. I need to get all things top variable on the left. So all things x on the left. So that's already on the left. That's already on the left. So x's don't need to be moved at all. How about the e to the negative t? I need to move it, right? What's it going to move over as? That's my question. Because technically you're dividing by it. You're doing 1 over e to the negative t. What is that, though? E to the t. Yeah, that's going to move over here as e to the t. And then I'll whip my dt over. When you divide, you're actually it flips as e to the positive. All right, my next step is what it's always been. By the way, I can't find c right now. I haven't integrated yet. So Felicia, my next step, nice easy antiderivative for this one. X squared over 2. What's the antiderivative of e to the t? E to the t. What if it was e to the 5t? Be careful. I asked this yesterday. What did you say? Be careful. Yes, be careful. It'd be 1/5 e to the 5t. All right. Could I find c right now? Yes. Let's pretend that Mallory decided to do that. So I just want to show you how it doesn't matter. So she's going to say, I'm always going to find it right away. All right. She needs to go take her 0 and put it in for what? T. Yeah, this is x of t, like f of x. So 0 is going in for t, and a 1 is going in for x. So she'd have 1 squared over 2 equals e to the 0 plus c. You just have to be really careful with your arithmetic, right? So Ellie, she's going to have 1/2 equals 1 plus c, because anything to the 0 is 1. What's her c right now? She has to put it in right now then. Does that make sense? She can't wait. It's going in right now. So I'm going to scroll and I'm going to continue on as Mallory finding it right now. She just found it to be -1/2. It's going in. All right, I got to look at what it's going into though. So she's going to write x squared over 2 equals e to the t minus 1/2. Are we good so far? This is actually kind of a tricky lesson. She's still going to solve for x. What will she do right now to solve it for x? Yeah, Caden. Multiply by 2, everything. So she'll have x squared equals 2e to the t minus 1. And I'm going really slow. Now what, Caden, then, since you started me?
Square root of both sides.
Okay. Now, when I square root, I need a plus or minus, correct?
Yep.
You have to, this is super important what I'm going to say right now. It's not always positive, it's not always negative, but it's not both, because it can only spit out one point. It's a function. Okay, does that make sense? So you have to decide which one it is. Okay, is it positive or is it negative? Here's how you decide that. You go back up to the initial condition and you look at what it's spitting out. When you put in a 0 for t, is this supposed to spit out a positive one or a negative one? What did it tell you? It's supposed to go through 0, I don't remember. 0 positive one or 0 negative one? Positive one. So it's not going to be the negative. You use the initial condition to decide between the plus or minus. If it had said x of 0 equals negative 1, does that make sense? Then I would have put a negative in front of it. So this is Mallory doing it right away. Right behind her is Charlie, and he's like, you know what? I'm in the zone. I'm gonna wait. Okay? I just super slow through this one just to show you it doesn't matter as long as you do it correctly. So Charlie's like, no, not doing it. So he's gonna start going, well, x squared would equal 2e to the t plus twice a constant is just another constant. Whoops. Why did I write to the x? Sorry. X squared equals 2e to the t plus c. This is him waiting. All right? He's going to say, well, then x is equal to plus or minus the square root of 2e to the t plus c. He's going to make his plus or minus decision based on the fact that this is spitting out a positive 1. So he actually knows that he's the positive. Now watch him solve for it right now. Are you ready? He won't get the negative 1/2 that Mallory got, because he's doing it at a different spot. Watch. He will still put in for x a 1. He will still put in for t a 0. Right? So he'd have e to the 0 plus c. He'll square both sides. What's he getting? What's his c? Negative 1, correct? So watch his answer. X is equal to the square root of 2e to the t minus 1. What did Mal end up getting, though? The same thing. Do you see? But her negative 1/2 had to go through some numerical manipulation, where yours just comes out at the end. Which way do you like better? The first way? Great. Then always find it right away. And make sure you put it in right away. And if you double, double it. Does that make sense? And if you multiply by 3, multiply it by 3. Charlie didn't have to do any of that because he waited till the very end. It's kind of weird, isn't it? All right, so I'm going to have you go try one on your own. Go to the next page. Again, kind of lots of notes today, but it is what it is. I'm going to have you take this whole one on out to the end. I'm going to stop recording just not to use up so much. But the keys have minor issues. And it's my first year using it, so I don't know what they are yet.